Hello, good afternoon, everyone. Welcome to this research conference webinar. I'm your host, Anthony Rushton. Today, we will be talking about the subject of our autonomous drones and air taxis coming, and how do we integrate them alongside passenger flights. Today, I'm joined by Andrew Sage, the Director of Transformation here at NATS, and Yijun, the Senior Lecturer in Computer Science at the Open University. The session is going to be recorded and put onto our conference website, and any questions, we'll try to collect them at the end. If we can't get to them, please reach out and contact us, and we'll try to respond. So to start with, I want to set the scene for today's panel sessions. I'll give a brief introduction. The subject of autonomous drones and air taxis gives some interesting opportunities and subjects. The first and foremost is the diversification of new airspace users. The current technology for air taxis and drones are giving us a new forms of air transport in the form of advanced air mobility, giving some really fascinating and diverse characteristics for transversing our airspace. The small UAS or uncrewed autonomous systems are allowing us to move small packages, or perform surveillance or search and rescue using small, lightweight electric drones that can do different types of airspace that were previously not accessible to previous airspace users. EBTOWs, it's an acronym of vertical takeoff and landing, using electric propulsion, is an interesting new technology that is allowing aircraft to use batteries to take off vertically and transverse into our more urban areas, transporting people in more of a taxi-like on-demand service. We're also getting electric regional and hybrid aircraft that are allowing us to move towards more greener, more sustainable type propulsion devices that are giving us new ways of transporting large numbers of people from and out of our regional hubs. But also there's different types of airspace access that is coming about. We're also seeing more opportunities at very high altitudes, reaching all the way up to 60,000 feet into the stratosphere. High altitude pseudo satellites allowing us to place remotely operated aircraft for long periods of time above us, our skies, for different types of surveillance and communications. We're also looking at the potential return of hypersonic aircraft, age of Concorde, where we can transverse across the world at much higher speeds. And there's also the exciting potential market of launching small microsatellites, either horizontally or vertically, outside of small space hubs. What all this technology from autonomous drones and air taxis has given us is new ways of integrating new users using different types of technology. What blockchain technology and other types of distributed and resilient types of infrastructure, allowing us to connect and communicate and control our aircraft in new and more robust ways, building a more efficient and optimized type of environment with a known traffic environment, allowing the best and optimal use of our airspace, and providing great levels of safety and assurance to our airspace users. This comes into our final subject of increasing levels of autonomy and automation. The new types of drones and uncrewed remotely piloted aircraft allow ways of automatically taking off and landing using more autonomous machine learning driven artificial intelligence, allowing us to take off and land in a more efficient and more optimized way, reducing potential workload for our air traffic controllers, increasing reliability, increasing the capacity to control and monitor the most important elements of the mission, and most importantly, allowing the human being to make the key decision making and leave the more autonomous and repetitive decision makings to the machines. So, Andrew and Ijun, could you give us an introduction about yourself and your work, please? Andy, you start, please.
Thank you, Anthony, and good afternoon, everybody. I'm delighted to be here. As Anthony said, my name is Andy Sage. I'm Director of Safety Transformation at NATS, which basically is code for the fact that I'm responsible for developing NATS's strategy and approach to integrating all of these new types of airspace user that Anthony has spoken about into the UK airspace, both within controlled airspace and all the other airspace that we provide services and data for today. And as Anthony has said, that already ranges from passenger taxis to delivery drones to high altitude platforms and all the variety of vehicles that have been spoken about already. And I look at that from a technical, regulatory, operational safety perspective as we endeavor to try and provide access in a safe manner to all of these new users. Thank you.
And Ijun, could you tell us a little about your work at the Open University, please?
Oh, thank you, Anthony. Yeah, my name is Yijun. I work at the Open University as a senior lecturer, specialized in software engineering and for safety requirements and the technology to enable safety. For the work we do in terms of the safety flight of drones, we started with looking at the problem incidents happen in the real world and trying to figure out what's the best way to capture the evidence for the incidents and how to make sure the incident evidence are made trustworthy, so we can actually show to the insurers or show to the various vendors what really happens. So in that respect, we take the technology like blockchain solutions into our thinking, into our plan to engage with NATS on how to regulating the drones. So this was the work has been done for at least 3 years now. And so I'm very glad that I'm invited to share our thoughts and also to try to understand more from the real world situations. Thank you.
Thank you, Yijun. So my first question is that there have been announcement recently of some companies winding down their drone delivery R&D efforts. Is this an indication of a trend in the market? Has the promise of autonomous drones and air taxis been perhaps a little overhyped? Andy, perhaps you'd like to answer the first question, please.
Yeah, thank you, Anthony. Let's give me the easy question to start with. No, I don't think they've been overhyped, but I think the reality has bitten. This is such a broad market with so many different types of vehicle, so many different applications. I think it was inevitable that some of these areas were going to find traction much quicker than others. The areas that I think we're seeing succeed and perhaps come about quicker than normal, I think are those that A, have a clear customer in mind, better still a paying customer. You know, there are some long range beyond visual line of sight operations that are already gathering revenue because they have been well targeted on a specific mission. Because we have to remember that these operations are not there for the sake of it. They are there to deliver a business mission. And secondly, have been able to quickly get flying in the airspace because of the location they're flying in. It means that we or others have been able to provide services to them that have enabled them to cooperate with other airspace users and find a way of safely flying on a sustainable basis without repeatedly having to close down parts of the airspace, which is hugely disruptive to others. I think delivery drones depend from day one really on a level of automation in the vehicle and also a level of digitization in network and services, which makes it a difficult segment to kind of evolve in a natural way. That segment in particular, it's now clear, requires much of what the airspace modernization strategy here in the UK is promising to deliver. And so I think a lot of the players that perhaps hoped things would be easier than that have discovered that. whereas I think others are finding a way to get flying and learn as they go.
Thank you, Andrew. And it's certainly going to be exciting to see which are going to be getting flying first, and then what their solutions are going to be. The opportunities and the market seems to be at a really exciting time to try and to discover who will get there, who will get into the airspace. Yijun, maybe I can turn and ask you what your take is on the market of autonomous drones from the more academic university's perspective.
Yeah, to us, that academics, we look at the problems more from the optimistic perspective. So as Andy just said, there are many different types of drones, and they are different types not because they are not only because they are designed differently, because they are fitting for different purpose and different contexts of use. So, for example, delivery see a more opportunity when you get the cargo to deliver the virus protection vaccination tools to the right people at the right time. That's one interesting application domain. But on the taxi situation, then you definitely need more safety regulation to be satisfied for them to take flights. So for the drones, such a versatile equipment, you see that's a small, nail, small hammer, but it can tackle a lot of nails. So in that sense, thinking about the application scenarios more than just treating it as one piece of equipment is more important way of thinking academically. We often call this system of systems thinking. In terms of the wide range of the value drones brought to the economy in the UK, we just see this marketing report by TWC says that there's 42 billion economy pounds by 2030, and it anticipates that the number of drones flying across UK sky will be 76,000. So I think that's a rather underestimated number. Just imagine I personally own 2 drones myself. So, but when people use the drones for different purposes, either it's sightseeing or whether it's delivering some goods for people, the challenge is always, is that the best way to use the drones, or whether you find a challenge that this drone failed to deliver things it's designed to do, and that give you a opportunity to check whether there's some additional intervention can be made into the more profitable use of drones. So in the longer term view, I'm fairly positive. So even if it's not flying to the Mars or like everyday use, but even everyday use is a huge market already. Not to mention in the Mars or other scientific project, drones can be used there. In relation to NATS, especially for air traffic management with the passenger flights, I think the airspace interaction between drones, the unmanned equipment, and the passenger flights, the manned equipment, is a very interesting one. And I guess regulation, especially for such a regulated market, will mark a healthy growth for the drones, flying without too many safety issues. That's the things people mostly worried about, and probably will you see a booming market once this issue can be resolved. Yeah, so that's my statement.
Oh, Yijun, maybe staying with you from the academic perspective, can you shed some light on what the funding landscape is looking like in this area, and how that investment is looking as a proxy for the growth in this space?
Yeah, I don't have a full picture of which people got which project on the funded research, but as far as I know, the funding agency at the UK alone has been given money to grants working on drones. So EPSRC has several projects ongoing. EPSRC is our national funding agency, and also we have the European project funding the different trial for the technical readiness of the project, including the ones we got for the Engage KTN knowledge transfer network. It's a small part, but definitely you can see drones is used as an exemplar for many self-autonomous, self-driving vehicle research. So people can use it to test out the research ideas, and not only those that immediately get benefit from the drones. So I can tell you one thing is, what I know is people work on software engineering as a researcher typically use drones to demonstrate their research, whether it's algorithms or whether it's different ways to check the requirements is fully implemented. Drones is a very visible entity to demonstrate that. So yeah, this is a promising area. I'm pretty sure there will be more grants coming to cover this space. And not to mention a lot of interdisciplinary study where drone is playing a part of it. So yeah, I think that's a good good area for the growth in the academic sense. There's a new transaction journal on autonomous and automation transactions. That journal published a lot of paper about drones. So it's seeing a lot of publications in this area as well.
We are seeing in the research and development area some funding grants in Europe and in the UK, future flight projects that we really enjoy engaging with universities. And as you mentioned, the project we recently completed between NATS and the Open University was a nice example of that from the R&D funding perspective. Andy, perhaps you can tell us a little bit about what you think are the other key enablers for new airspace entrances, like drones and air taxis, as well as the funding, the technology.
Yeah, I think, I mean, let's be clear, this is a brand new ecosystem that has to be created here between the vehicle, the vertiports, the airspace, the ground infrastructure, and getting them to all come together magically is a significant challenge. I think in terms of what is necessary to enable, early flights, then clearly, there are many companies racing to become the first to be the first to certify some of these vehicles, and there are still some major hurdles to be overcome there. But I think that where communities on the ground are used to the idea of existing EVTOLs, known as helicopters, flying already, then I think the obstacles are quite low. I think those operations can happen quite quickly. And with that will come familiarization from the public, a level of acceptability from the point of view of noise, environmental benefits, etc. And that in turn, I think, will then build the case for the more drastic changes that need to happen, both on the ground and in the airspace, for this to then become something that is commercially sustainable and scalable. This is not an industry that is scalable in the way in which we are constrained in the way in which we manage the airspace today. And for that, we need the digitization of existing services. We need a full surveillance environment in which we're able to see all of the other users that are interacting in the airspace. And we can't do any of that until the roles and responsibilities of all of the parties are clarified. I think we all know the bits that are necessary to pull this together. But we are partly constrained at the moment by the regulatory frameworks that we have, which are simply not built to provide services of this kind. So the changes that are necessary to be made in terms of investment and the airspace changes will have to occur, but those are not going to happen without both vehicles flying and social acceptance. And I think those will form the critical path towards this market being enabled.
Well, thanks, Andy. I think there's some really clear opportunities there and challenges that we need to address in order to enable this market. One of the things I personally love working with universities for is they give us the perhaps the more long-term perspective. And Yijun, I was wondering from your more kind of academic viewpoint, what do you think are the mid to the longer term key challenges that need to be addressed here?
Yeah, I can say for myself, like the research we do are usually thinking ahead of the time, like in the trajectory of 5 years or 10 years. So problem that can be solved immediately may be an interesting problem, but the interest will only last for the duration where the problem hasn't been solved. So in terms of the drones, the technical challenge is huge in terms of research. So one thing I can say is about the resilience. So you want the drone to fly and fly resiliently. If there's a non-nominal situation that are unexpected at the design time, it could occur when it's operation. So such a situation requires the design to make the drones more resilient. So that typically can't come out of the box. You get the drones out of the off the shelf. Is not ready for such resilience. You have to integrate it with more self-adaptive algorithms where the system can monitor the situation around it and foresee or react to the non-nominal situations, so it can actually deliver its promise. So in that aspect, it is not uniquely different from autonomous vehicles or other underwater boats if you see them in the same situation. The only difference that mark the drones so much different from the other device which require the self-adaptability is the situation is in the air, and if it fails to deliver its promise, it either crash or hit someone hard, and that's very scary picture. So that area by itself is very interesting. And to add the interest of NATS perspective, I think the safety of passengers, whether they are flying in the traditional airplanes or the futuristic air taxis, the situation will be even harder, more challenging to make sure the safety of the cargo, or let's say the passenger, even more important than the safety of the drones or flying vehicles. So that part, I think we need a lot of studies, both as Andy said, on the social aspect and also on the technical aspect. Social, technical, and cyber. So we call that very important cross-cutting dimensions of the research. So Engage KTN give us this opportunity to work with NATS earlier, and we see already 8 very concrete scenarios where the drones are used, interacting or interfacing with the manned space. And that gives us a lot of opportunity to think about the various algorithms in this space. And if we can and actually work on this for a longer period of time, we can solve a fraction of this problem in the real world. I think that worth all the effort. We'll keep doing what we wanted to solve in this domain. Yeah, so I guess if you want to see more research happening that can help solving problems, the first thing to do is always testing the waters. So we bring our initial solution to NATS and we look at it whether it fit the scenario or not. That's the first step. I think there's no way to do things just in the ivory tower to face the real world problems. Yeah, so I think that's my take on this problem.
Yeah, thank you, and thank you. I see Bashir in the link has in the chat has posted a link to one of the UK's UK R&I's projects there in this area, so part of research area worth looking at. But I mean, Andy, do you think that what challenges there are to the operational side of the business once these types of operations are scaled up into this more theoretical, distant future?
Well, I wanted to build upon Ijun's topic of resilience, really, in terms of trying to achieve an operation that can be dependable day on day. Because if this isn't a service that can be depended upon and is subject to too many variables, then it doesn't become a serious business proposition. And if I think about the different operators that NATS has worked with so far, in order that we can try and understand how these various use cases impact upon our operations today and how we need to adapt in order to accommodate them and allow them access to the airspace, the conclusion we've drawn in every case is that it is so invaluable to be able to examine the airspace alongside the aircraft and allow the two to be developed alongside one another like a hand in a glove. It's inevitable, really, that especially in areas like air passenger taxis, that all the attention so far has been on the development of the vehicles, and we've all seen the number of sort of future and firm orders that have been placed with some of the world's largest manufacturers just in recent weeks, never mind months. But I think the time has come to look at how they are best designed in order to operate effectively within the airspace. I mean, let me give you a very specific example. If you look at the way in which we managed to allow helicopters to share the airspace with passenger vehicles across London today, we have a set of services that rely quite heavily upon helicopters being able to hover in the same place while waiting for traffic to pass. Now, if at the same time, battery technology is still a challenge to manufacturers, then they're not going to be too happy at hovering and remaining still for a long period of time. I think that's probably going to use up a lot of power. And at the same time, there won't be a lot of places to divert to in the event of emergency or loss of power. So, I think there is a real risk of either underinvestment or overinvestment in certain aspects of the vehicle, unless we start to consider at exactly the same time how the airspace is going to evolve over time to reach that level of resilience, as Yijun put it.
Oh, thanks, Andy. I think that's so key. I think airspace and resilience seems to be the theme that comes out there. How do we make our airspace more resilient, and perhaps that makes it a little bit more robust to some of our new airspace users. I know that some of the NATS R&D research activities and several concept of operations that we've been looking at looks at how do we integrate different airspace users into the single shared airspace. At the end of the day, the oxygen and the air above us doesn't have boundaries, and we have one airspace that we have to make it as resilient all the way through the supply chain, from providing our customers exactly what we need to providing the safety levels and the assurance that these operations can be integrated, but they can be scaled up in a safe way, in a sustainable way. And that's a lot of what we've been involved with in Cesar and Future Flight projects. And another project that I wanted to mention was the Safe Drone Flight project that we worked on between NATS and the Open Universities. It is another example of where we looked at some of the details of how a distributed blockchain technology can be providing resilience into the overall ecosystem, how all the air traffic management comes together into one unified set of systems that provides that resilience of allowing drones to really do what they need to do, while airspace users can also do that as well. And by any of our listeners who are interested in that project, we can point them a little bit more to that project. So, Andy, I have a question for you. What are the main challenges of the airspace when the new airspace users have such different characteristics and behavioral types? How has that evolved, changed over the years?
Yeah, I think that's, go back to the first question. I think that's the revolution that is now necessary, that has perhaps cause some of these segments to sort of falter. If you think about the way in which the airspace has evolved over time, it has largely resulted in a system in which we have dedicated classes of airspace designed to meet the dedicated types of aircraft. And you get very little mixing between the two. And I think that system is probably now stretched as far as it can do. It's simply not sustainable going forward. It's no good telling a medical helicopter to go in a different part of the airspace to a COVID delivery. They both want to go to the same hospital. It's no good telling a drone that is surveying offshore oil and gas platforms to go to a different place to helicopters. They both want to go to the same place. It's the whole purpose of the mission. And I think the problem is even more acute when it comes to air passenger taxis. If every time we wanted to set up a new route from A to B, we went through a process of airspace change to set up dedicated corridors, which, for good reasons are important, transparent processes that allow the public and other stakeholders to consult and examine the impact. Then this market might never take off, and so we simply have to find a way of accommodating those different users and allowing them to share the same airspace. I think where there is a very common level of autonomy and capability, such as there might be for small delivery drones, low level in urban areas, and I think you have the potential to delegate parts of the airspace to operate in that manner. But as I said, I think the early market segments that will succeed are those that have a clearer business objective, where perhaps you will see a mix of manned and unmanned and different levels of autonomy for years to come. And ultimately, the only way to achieve that interoperability and to make sure that everyone still has access to the airspace that they have today, is through a set of airspace management services that allow them to do so.
I think that's a really key distinction we have here between delegating a block of airspace, so maybe they can autonomously self-manage themselves, and the difference between delegation and segregation of a block of airspace. We do have some really nice research technology demonstration volumes of airspace that block off and demonstrate maybe a key component of some technology, and that's really, really interesting projects coming out there. But the challenge from my perspective is that how do we scale that up? I mean, we could perhaps do that for one or two or a handful of a particular type of mode. But if we want to really realize this market of how digitized technology works, we're going to have a way of allowing that for everything. And I think everything's on the table here, and parts of airspace delegation and allowing resilient systems to do what they do best, I think is really key there for the future. Then maybe, Yijun, I can turn back to you talking about future systems. What does the aviation industry need to prepare for in the real long term, and what the fields of research are on the horizon?
Oh, yeah, that's a very good question to help us to strategically think what the research direction to go. As Andy just said, there is no boundary in the air, and each mission of the drones could interfere or interoperate with other mission of the drones. So when you have one or two such interaction, that's probably okay. You can do this case by case. But when you want to make sure that the drones are flying in a large scale, are all obedient or actually regulating against these laws for them to fly safely, and then we need a very different level of monitoring and interaction. So we see this blockchain technology being fairly capable to scale up. And when you consider doing transactions to share money between people in the large numbers, it has been proven that using distributed ledgers, you can actually have an integrity and also have immutability on the evidence of transactions. So let's say if we do all the monitoring of the work and putting the evidence into the blockchains, then we can have a very good understanding of this shared space because they are shared in the ledgers. And we have the good understanding of the interaction because this can be timestamped and immutable, and there's no dispute against who did things right or wrong. But the challenge for the research is that blockchain technology was designed for making financial transactions initially. It hasn't taken into account the amount of data we could gather with the drones, and every single point of flight, you need at least the coordinates and the speed and the orientation information to make a very basic analysis of what's happening with the drones and the aircrafts. So in that sense, we need a much more scalable blockchain technology to get this right. The second promising thing I see recently is this Rust programming language. It was designed to replace traditional programming language to offer memory safety. But as you can see, memory safety is so critical for the system at this scale. So a lot of blockchain solutions, modern ones, not just the Bitcoins and Ethereums, those recent ones actually move on towards Rust. And there are several very good contenders to offer the scalable solution using Rust to implement. Just before this meeting, I had a chat with the CTO of a drone company, and they actually developed the drone microcontroller using Rust. And this guy was actually the standard library team lead of Rust programming language. So there's quite a good momentum in the community to work towards a scalable solution. So the convergence of the blockchain and the Rust would help us to build a very scalable capability to verify the traffic of the drones and to avoid undefined behavior, not only in the physical sense, but also in the program sense. And this type of solution, I think, is just around the corner in the horizon now. But thinking ahead even further, if we have the blockchain Rust working together, can we make the arguments of what's happening with the incidents more scalable? So there's also some recent proposals for the Ethereum 3.0 to support this argumentation language called the zero knowledge snarks. And that's an area where you might even address the scalability of the ledgers. So it's no longer 100 gigabytes for the shared ledgers. You only need 20 kilobytes to save all the evidence of the recent mission for the drones. And that hopefully will help us to address that challenge we faced. But this can't come in a year time. I believe it will take several years to get to the level of technical readiness. Then we can actually try it out in the real world and see how it works.
Thank you, Yijun. Really interesting perspective. I know I've heard blockchain as being a proposed solution for a lot of different industry challenges. Some of it's quite exciting. I think it's fair to say a lot of it hasn't been realized in the today's operational world, and you know the issues of how we store so much data and these machines. These drones and these air taxis will produce huge amounts of data. I don't think that technology is quite ready there for today's operations. But I think one of the key take home here is that the principles of how we cooperate and how we hold each other to account through more digitized processes is really key here. And I suspect there will be some elements of the principles of distributed digital ledgers, as they're known, into today's operations. That is going to be some of the keys to realizing some of these research challenges. So I got one of my last questions, and this is probably interesting is, do you both really think that autonomous drones and air taxis are going to be coming to our skies anytime soon? Perhaps Andy, you can, or
Yeah,
this is no question really for you to really set the scene for.
Okay, I'll give you my thoughts. I think they are undoubtedly coming. I think the more interesting question for me is whether they're here to stay. I think they deliver potentially such enormous benefits in terms of reduction of CO2 burn, greener vehicles, increased urban mobility, connecting remote communities. We're already seeing some of that happening with deliveries already. So, I think inevitably they have the promise of such enormous benefit. But I think whilst we're able to accommodate them to a certain degree, and NATS stands ready to accommodate any number of these new vehicles and applications to the extent that we're able to within the limitations we have today of our airspace and the services. I think for them to be here to stay requires so many of the changes that we've discussed today, technically, safety, regulatory wise, that is clearly much more uncertain. But I think, based upon what I know, I think it's reasonable to think that we're going to see, some of these larger vehicles certified and ready to at least be tested in our skies within the next 5 years for sure.
And Yijun, same question. Are autonomous drones and their taxis coming?
Yeah, I see it's coming the same as Andy, but I also put a big question mark for them to be embraced. We need to make them safe. But how do we make them safe is that we have the evidence to show they are safe. So in that sense, capturing the data about the airspace, not only the flights you are cared about, but also the surroundings, including the unmanned vehicles or manned vehicles, and also not to forget the users that take the taxi or the user take the flights. They have their own mind or the goals to be satisfied. So putting all this together, the future of travel do need we call that digital twins, where we get the real world information stored in the digitalized form, so we can make the arguments whether or not the flight is safe. So we often call this assurance case to say we have assurance this vehicle will fly safely. With the evidence back this up, I think the future will be safer. So digital twins and assurance case is my two secret sauce to say how to make this happen safer. So it's definitely coming. I can't tell 5 years or 10 years, but it's definitely coming.
Yeah, I think the technology is really, really fascinating and interesting, and you're completely right. Putting this together and creating the evidence and the data that does that is the way that we take this from perhaps the research elements we are talking today to the established operations of tomorrow. So I'm going to close on that, and I'm going to say thank you to everyone who's been watching this afternoon. I hope you've found this both interesting and fun. Certainly, I've enjoyed this a lot. And we're really encouraging you here to provide feedback to us. Any ideas or suggestions you've got from the work that we're doing and this research conference, please email us at researchanddevelopment@nats.co.uk and share your thoughts with us, please. We really value your feedback here. And on that, I'd like to thank our two panelists and say thank you to everybody and have a good day. Goodbye.